Hi girls, today I'm going to explain about the operators, bitwise operators. In my last two classes, I explained you other type of operators in C. This is the last one, bitwise and special operator. So now today I'm going to explain these two operators in C. The first one is bitwise operators. In the C programming language, operations can be performed on a bit level using bitwise operators. Okay. Perform operations on a bit level using bitwise operators. These are the following bitwise operators. This is the symbol of the bitwise operators. This is the meaning of the operator. Okay, here single ampersand is used for bitwise AND because we have logical AND operators in C. For the logical AND operator, double ampersand was used. Okay, so to differentiate the bitwise operator with logical operator, here single ampersand is used for bitwise AND, like that single pipeline symbol is used for or bitwise OR. So the different to differentiate the logical and logical OR, here the bitwise operators are specified as ampersand and pipeline in C. Okay, and then bitwise exclusive OR left shift, right shift, and bitwise NOT, that is called one's complement. Okay, so these are all the bitwise operators in C. Let's explain you in detail what are all these bitwise and bitwise OR, bitwise exclusive OR, shift left and right and NOT. Okay, complement. These are all the operators and meanings of bitwise operator. This is the what is OR operator, what is exclusive OR and what is not, or explain here. I already explained you in the logical operator what is meant by OR and and also not. Exclusive OR is only new to this. Okay, so OR, what is the operation of OR is OR return the value 1 if either one of the input is true. Okay, so returns a 1 if either one or both of the bit compared is a 1. If both bits are 0, OR returns 0. Okay, this is the rule of OR, and the rule of AND is AND return 1 if both bits are 1, otherwise it will return 0. Okay, if the both bits are 1, it will return 1, otherwise it returns 0. So this is the rule for AND. So now the exclusive OR is it returns 1 if only one of the bit compared is a 1. If both bits are 1 or both bits are 0, the exclusive OR returns 0. Okay, that means if two bits are in opposite, it returns 1. If two bits are same, it returns 0. Okay, so NOT means it complement each individual bit. If the bit is input bit is 0, it is converted into 1. If the input bit is 1, it is converted into 0. This is called the NOT. This symbol is called the tilde symbol. Okay, this is the example for bitwise AND. So bitwise AND means in bitwise AND we are all give the input in the binary format only, that is a bit. Okay, here the binary representation of 10 is displayed here. This is the binary representation of the 2. Now we are going to AND the A and B. Okay, bitwise operations are going to perform. So single ampersand is used here, not logical AND. So A and bitwise and B. Okay, so here the AND operation will be if the both bits are true, the result will be true. But here the first one is 0, that means false. The second one is 0, that is also false, though the output is false. Okay, in this bit, the first in this bit is 1, that means true. This is also true, though so the output will be true, that means it represents 1. Here you can see in this bit, this is 1, this is 0, that means this is true, this is false, so the output will be false. Okay, so if the in AND operation, if both bits are true, the output will be true, otherwise it will be false. Okay, this is the truth table of bitwise AND. Next one is bitwise OR. The bitwise OR means either one of the bit is true, the output will be true. If both the bits are false, the result will be false. Okay, here I shown you how you convert the decimal number to a binary number. For example, I give 12 in this example. Take that number 12 and divide by 2 and choose the remainder from the downwards to upwards. Okay, from first you choose the 1 and this 1 and 0 and 0, but only 4 bits are there. 8 bits equal to 1 byte. So in the remaining part I placed 0 in the most significant bit. These 4 zeros are called most significant bits. These 4 bits are called the least significant bits. Okay. So this is the OR operation performed here. This is the symbol of the bitwise OR. In OR, either one of the input is true, the output will be true. So this is false, this is true, the result is true. Both the conditions in OR operation, if both the conditions are false, the output will be false. Here also this one is true, this one is false, the output will be true. Here both are true, the output will be true. Okay. Here this one is false, this one is true, the output is true. If both conditions are false, the output will be false. This is the rule for the bitwise OR. Here the number is converted into decimal number 21. The result of the bitwise OR is converted into decimal number 29. Okay. This is the bitwise OR. Next one is bitwise exclusive OR. The result of the bitwise operator is 1 if the corresponding bits of the two operands are opposite. For example, if the two bits are opposite, it reply the 1. If the two bits are same, it will result the value 0. Okay, this is the rule. If the two bits are same, the result will be 0. Okay, if the two bits are opposite, the result will be 1. For the same digit I chosen here, 12 and 25. This is the binary representation of 12. This is the binary representation of 25. Here 0, 1. The two bits are different. This is 0, this is 1. So the output result will be 1. In exclusive OR, if both the bits are same, result will be 0. Here this is the two different. The first one is 1. This is 0. The two bits are different. So the result is 1. Here the two bits are same. Here also 1. Here also 1. So the result is 0. Once again I repeat this, girls. If the two bits are same, either it may be two zeros, either it may be a two ones, the output will be the result will be 0. If the bits are different, the result will be 1. Okay, this is the rule of bitwise exclusive OR. So this is one of the important concept in C. Bitwise right shift operator. It is denoted by the symbol 2 greater than symbol, because already we have single greater than symbol was used in relational operators. So the compiler want to differentiate the both. So in C, shift right operator is mentioned using the greater than 2 greater than symbol. Okay. How the bitwise shift happens here is, bit pattern of the data can be shifted by specified number of positions to right. Here the bits are moved towards right. So okay, if we give 2 bits, it will be moved towards the 2 bits shifted towards the right. If you give 3 bits will be shifted. Okay, like that. When the data is shifted right, leading zeros are filled with 0. Okay. By right shift operator is a binary operator. Binary means it has two operator that require two arguments. Here I shown you the example of the right shift. I give the value 7 to x, and this expression is x right shift by the 2 bits. Okay, position, how many bits we are going to shift is 2 bits. Okay, here this is the binary representation of the number 7. 111 is the binary representation of the 7. We have 8 bits, so I place these zeros before the 3 ones. Okay. Here the right side, from right side we have to shift 2 bits. Okay. From this is the right side. I discard these 2 bits. This is the first bit, this is the second bit. I discard the 2 bits and I assign the third bit to the first position, and the fourth bit to the second position, and the fifth bit to the third. Like that we shift the each bits. Okay, the last 2 bits, 7th bit and 8th bit was empty here, so that empty place we replaced zeros, we replaced with 0. Okay, so the final answer is 1 0 0 0 0 0 1. Okay, this is the right shift operation, so the result is 1. This is the right shift operation in C. Okay, the 2 bits are shifted, so these 2 bits are empty now, so you have to shift the third bit to the first place, fourth bit to the second place. Like that you shift each bit, so the 7th and 8th bit here will be empty, so that it is replaced with 0. Okay, this is the right shift operation in C. So next, the left shift operation. This is the left shift operator is 2 less than symbol, because already in relational operator we use one single less than operator for comparing the less than numbers. So here it uses a 2 less than operator. Left shift operator shift all bits towards left by a certain number of specified bits. How many bits if you want to shift? If you give 2 bits, it will be shifted, it will be shift 2 bits towards left. If you give 3, it will shift 3 bits towards left. Okay. The positions that have been vacated by the left shift operator are filled with 0. The symbol, the left shift operator is 2 less than symbol. Here I should give the same 7 for the example here. This is the binary representation of number 7. I'm shown here, this is the binary representation of number 7. Here I shift only one position by left. Okay, so this is the left one bit. I shifted this one bit towards I shift one bit out, so I replaces this bit towards this here, this one here, this bit to here, this one to here, this one to towards here. The last one was empty, so I replace it with 0. Okay, so this is the left. The direction I shown you, this is the right bit direction, this is the left bit direction. So this is the leftmost bit. I discard this left first bit 0, and then I replace this 0 to here, this 0 to here, this one to here, this one to here, and then this one to the this is the third bit that was transferred to the fourth bit here. This is the second bit transferred to third place. The first bit transferred to the first place. Here the first bit was empty, so it replaced with 0. Okay, this is the left shift operations in C. So this is again an example of the left shift. I give the binary value 00110011. Number of bits shifted here is 2 bits, and the left operand shift specifies the value to be shifted is 2 here. Okay, so the leftmost 2 bits in the example A is 0 and 0. So you discard these two zeros. Okay, so this will be the empty. After that, the third one only the here. So this one replaces the 8th bit. This one replaces this place. This one replaces this. This 0 replaces this place. This one replaces this place. This one replaces this place. Okay, the last 2 bits here empty, so it is replaced with 0. Okay, this is called the left shift operation in C. So I shown you in detail. This is the detailed example how the left shift and right shift operates. This is the example of the first picture is the example of left shift. This here shift left shift by 1 bit. So this is the most significant bit of the left shift. So this one is showed as a light shade. So this was removed. So this place is now empty. So this empty place was replaced. This one was placed here. This one is replaced by here, this one replaced like that. So the last bit, the one replaced to the second place. So the first bit was empty, so place 0 on that place. So the direction I shown you, this is the direction of the left shift. For here, this is the right shift. The rightmost bit is this one. So this one bit was discarded. So this was empty. This one is replaced here, this one is replaced here, like that all the bits are replaced. The 8th bit was replaced here to the 7th bit. Now the 8th place is empty, so this is replaced with 0. This is the right shift operation. Okay, can you clear, girls? So the last one is the bitwise complement. It complement means it inverts each individual bits. Here in this example you can see this is the input number 4. The binary representation of the 4 is represented here. 100 is the binary representation of the 4. Here the bitwise complement means it converts 0 to 1 and 1 to 0. This is the input. The 0 is converted to 1. Here the 0 is converted to 1. The 1 is converted to 0. Here the 0 is converted to 1. So the result, the complement of the 4 is here minus 5. Okay, the input is 4, the output is minus 5. This is the bitwise complement operator. So this is another example. This is the input I given 000 111. This one is converted to 0. All the ones are converted to 0. 0 converted to 1. So the complement means the 1 converted to 0, 0 converted to 1. This is called the complement, 1's complement in C. These are the special operators in the C. This will be used in 4th unit and 5th unit. This will be explained detailed in the third unit. Okay, what is pointer, what is reference operator, address operator, negative value and all the things. Okay, the comma operator is used as a combine one or more statements in a single statement is called the comma operator. So these are all the operators